In this video, we are going to look at how to calculate the present value of an annuity. An annuity is going to be a finite series of equal payments that occur at regular intervals. Finite means that they occur for some amount of time less than infinity. Equal means that they are all equal, and regular intervals means that they occur with some consistent frequency. So for example, if we have payments that occur at the end of each of the next month or at the end of each of the next quarter or year, that would be at a regular interval. If the payment occurs at the end of the time period, it's called an ordinary annuity. And if the first payment occurs at the beginning of the time period, it's called an annuity due. At the top, we can see our equation. In that portion in brackets there, we call the present value interest factor of an annuity. We see our inputs, and the first one is time, which is going to be the number of time periods, or our years multiplied by the number of compounding periods in a year. So if we had an annuity problem that had monthly payments for 10 years, we would say that our T is going to be equal to 120 or 10 times 12. Our interest rate is going to be our annual rate, or an APR, divided by the number of compounding time periods within a year. Present value, that's going to be the value today at time 0. Our payment is going to be our annuity. It's going to be a finite series of equal payments at regular intervals. And then our future value would be any cash flow that occurs in the future. So in our first example here, suppose you will receive $2,000 at the end of each of the next 5 years. So we know in total we're going to receive a total of $10,000 in future value dollars. We know that the value of those cash flows is going to be a lower amount today because we'd be willing to accept a lower amount today instead of receiving that higher amount in the future. So we know our present value is going to have to be less than $10,000. We're going to assume a discount rate of 8.5% per year, or annual compounding, and we're going to find the present value of this steady and constant stream of cash flows. So here you see our timeline where we have $2,000 at the end of each of the next 5 years. And our formula. Again, it's going to be the present value of an annuity is going to be equal to the payment times the present value interest factor of an annuity. Our inputs, our payment is going to be $2,000. Our R is going to be 0.085 divided by 1 because it's annual compounding. Our T is going to be 5, and we're going to solve for PV. Here we see our inputs and the beginning of the equation. And we see the present value of this annuity is going to be equal to 2,000 times 3.940642. And the present value of this annuity is $7,881 and about 28 cents. So in this case, we would be indifferent, assuming that we could earn 8.5% per year. We would be indifferent to receiving a stream of $2,000 cash flows for each of the next 5 years, or the one-time payment today of $7,881 and about 28 cents. In our next example, we're going to assume that we have this product called an annuity. And an annuity is often an insurance product that's going to offer a way to provide some steady stream of cash flows over some amount of time. So as an insurance product, a lot of times insurance agents will suggest these as a way for you to manage the amount of money that you're going to be able to earn in retirement over some period of time. The challenge, of course, is to make sure that you get a good deal. You want to make sure that the value that they're charging for that annuity is consistent with the level of risk, and it makes sense for how much you're actually receiving. So in this case, the financial advisor is going to offer an investment, and they usually call it an annuity. Again, it's going to be an insurance product, where they're going to pay $2,000 per month for 25 years, and we're going to assume monthly compounding. If we can earn 6% per year as an annual percentage rate, we want to know how much we would be willing to pay for that annuity. And so our payment is going to be $2,000. Our periodic rate is going to be 0.06 divided by 12. Our T is going to be the number of time periods. In this case, it's going to be 25 years with monthly payments. And there we see our formula. And here is our setup. And so the present value of this annuity is $310,413.73. And so the other way to think about this is you could create your own annuity if you could earn 6% per year. And the annuity that you would be able to create is a series of $2,000 payments each month for the next 25 years if you invested $310,413.73. Again, though, you'd have to earn 6% each year and every year for the life that you were investing that money for.